Pluto is a long way far from the Sun, of course, so the solar is about 1,500 instances fainter than its miles right here on Earth. So it's very bloodless. Temperatures drop to around -230 degrees Celsius in the course of the midnight. In a warmth wave, you would possibly get as excessive as 170 degrees Celsius. It has a completely tenuous environment as well. Welcome, curious minds, to an exploration past the familiar realms of our Sun device. What if I told you that Pluto, the remote and enigmatic dwarf planet, is sooner or later making its cosmic move, doubtlessly colliding with none other than Neptune, the ice giant? Pluto's rebellious nature has been evident from the start, a renegade at the fringes of our celestial neighborhood. Its orbit audaciously crossing paths with another planet challenges the conventional norms of planetary conduct. I suggest that is no type of behavior for a planet. Right from the perplexing intricacies of Pluto's orbit to the raised issues voiced by means of astrophysical luminaries like Tyson and Kaku, a lingering question hangs inside the cosmic balance. Will these celestial giants have interaction in a collision path? Should the convergence in their paths spell unexpected results for our cherished planet Earth? Today, we embark on a cosmic journey filled with uncertainty. Even as the solutions to those celestial queries may additionally elude us for the time being, the capacity for a collision of such cosmic proportion serves as a stark reminder that the universe is a stage for events both awe-inspiring and perhaps a touch at the terrifying side. Join us as we delve into the mysteries that orbit our understanding of Pluto and Neptune, deliberating the possibilities of a celestial conflict that could reshape the cosmic balance of our Sun machine. The level is set, and the unfolding drama beckons us to witness the enigmatic dance of the planets. Among other potential space failures, the cosmos harbors an array of enigmas, and among them is the intricate puzzle known as the three-body trouble. But scientists foresee different potential cataclysms within the celestial theater. Despite the fact that a planet colliding with every other in space is exceptionally unlikely, it isn't definitely out of the question. Gravitational interactions, as defined by way of the three-body trouble, are one of the forces that have an effect on planetary orbits. An example of a space device where gravitational forces produce a periodic pattern referred to as orbital resonances is TRAPPIST-1, which has 7 planets the size of Earth. As time passes, those patterns might weaken planet orbits, increasing the probability of collisions. The current scenario does not consist of any collisions, despite the fact that systems including TRAPPIST-1 are very dense and planets affect every other's guides, particularly whilst they're close. Scientists frequently monitor those systems to understand this. With this information, we can better apprehend how the planets move through space. Another unknown known component is rogue planets, which drift aimlessly in space, alternatively than in orbit around a celebrity. Expulsion of planets from star systems can occur as a result of gravitational poles or other astronomical phenomena, such as another big name's near method or dynamic instability in systems with more than one planet. As time passes, these roving planets have the potential to tour amazing distances, probably even accomplishing regions far from where they started. It's far possible that they'll go paths with different star systems on their solo voyage. The opportunity of a planet-planet collision increases if this sort of planet travels to another Sun machine. Though a rogue planet striking another planet head-on is pretty not likely, considering how great and frequently empty area is. The sparsity of planets in open space and the immensity of interstellar distances work together to discourage common collisions. It's already distinctly unlikely that 2 rogue planets will collide, but the frequency of rogue planets is far decreased than that of stars and planets in solid orbits. The celebrity systems worried can turn out to be chaotic in the event of a galactic merger. It is particularly fantastic that planets will collide head-on for the duration of these cosmic events because of the vast interstellar distances. The orbits of stars and planets with rising galaxies are altered dramatically via the sturdy gravitational forces. A planet may additionally become a renegade world, free of any star, whilst this kind of chaos forces it out into the cold black depths of intergalactic area. Alternatively, planets can be expelled from their orbits, collide with each other, or even affect their host stars because of these gravitational disturbances. When fuel and dirt are compressed under extraordinarily high stress, gravitational rearrangement can really reason new celestial bodies to shape or perhaps begin stars to emerge. In our solar system, the late heavy bombardment shows that around 4 billion years in the past, there was a duration of expanded collisions concerning comets and asteroids. This surge in impact is believed to have resulted from gravitational disturbances as a result of the outer planets. During this chaotic segment, fuel giants inclusive of Jupiter and Saturn have been present process migration, disrupting the orbits of several smaller bodies in the Kuiper belt and asteroid belt. As a consequence, these smaller items were thrown into unpredictable paths, with many making their manner into the internal solar device. This inflow caused an extensive upward thrust in impacts on the terrestrial planets, including Earth. Whilst these collisions did no longer involve direct clashes between planets, they illustrate how gravitational interactions can bring about sizable changes within the trajectories of celestial bodies. This bombardment is notioned to have performed an important role in shaping the surfaces and geological histories of planets in our solar machine. Additionally, it could have contributed to the shipping of water and organic materials to Earth, influencing the improvement of our planet over an extended length. As stars undergo modifications in mass flows, then parts of planets round them can also wind and doubtlessly move. This is particularly considerable in structures where stars are on the cease of their life cycle, as a celebrity gets older and consumes its nuclear fuel. It regularly undergoes considerable mass modifications, specifically in the course of stages like the red giant segment or when it releases cloth in a planetary nebula. These variations in stellar mass can notably affect the gravitational balance of the machine, causing the orbits of close-by planets to either circulate outward or emerge as greater compressed. That is much more likely to happen in multi-famous person structures, where complicated gravitational interactions can without problems lead to risky orbits. In such structures, the gravitational forces from multiple stars can have interaction unpredictably, exacerbating orbital shift and growing the chances of orbits intersecting. This can bring about conditions in which planets might get captured by way of another famous person, collide with other celestial bodies, or maybe get ejected into interstellar space. Pluto's specific orbit, initially acknowledged as a full-fledged member of the planetary family, underwent a reclassification, in the end being designated as a dwarf planet attributable to its distinct orbit. The astrophysics network continues to be enthralled via it and reveals it captivating. Even with this amendment, there may be motive for issue regarding the closeness of Pluto's tune to Neptune's. In step with latest forecasts made via eminent scientists like Neil deGrasse Tyson and Michio Kaku, those scientists are sounding the alarm approximately a grave hazard to Earth, the possibility of a collision between the planets. Pluto is in contrast to every other planet in our solar machine, and that is what makes its orbit across the Sun so unique. Pluto has now not finished a full revolution when you consider that its discovery in 1930, and its orbit spans and prolonged 248 years. The truth that it deviates drastically from the roughly circular orbit of the huge planets makes its direction extraordinarily elliptical. In addition to its rapid rotation, Pluto also has a steeper orbit than the other planets due to the fact its inclination to the ecliptic aircraft is 17 degrees. Adding intricacy to Pluto's orbital pattern is the aggregate of its elliptical form and inclination. The factor wherein Pluto's orbit crosses paths with Neptune's is a thrilling characteristic. For the duration of approximately 20 years in each orbit, Pluto ventures towards the solar than Neptune, challenging expectations based on their respective positions in the solar system. This prompts the query, why hasn't a collision among Pluto and Neptune befallen? The explanation lies inside the gravitational affects exerted by way of different planets. The examination of Pluto's orbit commenced shortly after its discovery, imparting a difficult trajectory for astronomers. In contrast to the majority of planets whose orbits align tremendously close to the ecliptic plane, Pluto's special features encompass a steep inclination and an elliptical shape. The mystery deepened with the consciousness that Pluto's orbit crosses that of Neptune. The three-body trouble Pluto's orbit remains stable amidst the intricacies, serving as a testament to the inherent complexities of celestial mechanics. Comprehending the motion and gravitational interactions of three heavenly bodies like Pluto, Neptune, and the Sun is called the three-body hassle in space. Predicting their trajectories from their beginning positions and the results of gravity on every different is similar. For Pluto, a number of the terms that help to clear up this astronomical thriller are azimuth libration, range libration, and the VZK oscillation. According to astrophysicists, Azimuth libration is crucial as it maintains planets in their orbits. Whilst Pluto crosses Neptune's orbit, it's far at the least 90 degrees remote. This is a critical distance that stops collisions. According to this definition, applied to Pluto and Neptune, range libration relating to the vertical movement of a celestial body in its orbit ensures that when Pluto tactics Neptune or other large planets, its miles situated substantially above their orbital plane, providing an extra layer of protection in opposition to collisions. A key component in knowledge celestial movement is the VZK oscillation, named after three scientists, Van Lee and Kai. They explored the gravitational interactions between three space items, consisting of Pluto, Neptune, and the Sun. The aim is to anticipate the outcomes on their orbits.